Okay, so it's good to see everybody. Hope you're having a good afternoon. So the plan today, I want to go ahead and finish up 1.6. We're not going to have a whole lot to do with the end behavior. When we finish that up, I have a little activity that I'd like to go ahead and work with you folks. And then after that, with whatever time remaining, we'll go ahead and take a look at the homework. What's that? Oh, you say SEL? Okay. So 1.5, we'll start looking at the homework if you have any questions. And then tomorrow, right now, the only plan I have is to go ahead and take questions for the assignment. And then we'll go ahead and have SEL after that, finish off the week on a good note. Got a 3-day weekend. And then Tuesday, when we come back, we will have a quiz over 1.5. That being the polynomial functions and complex zeros. All right. So are there any questions about what's coming up? Okay, well, let's go ahead and get to it. Did anybody need a copy of the 1.6? Anybody need one? Okay, well, let's take a look. So yesterday, we started talking about end behavior. So when you're looking at a graph, all this refers to is the left side and the right side. Okay, what is the graph doing on each side? So as x goes to negative infinity, is it curving up to positive infinity, or is it curving down to negative infinity? Same thing over on the right. As x approaches positive infinity, is it curving up to positive infinity or down to negative infinity? We can describe this verbally. X is going to increase or decrease without bound, but we are wanting to make sure we're okay. That was interesting with the limit statements here. Okay, so the limit as x approaches negative infinity of f of x, that's the left side behavior. And the limit as x approaches infinity of f of x, that would be the right side behavior. Okay, so we went ahead and went through some examples, and everybody seemed to respond pretty well to those. All right. So now I want to be able to predict the end behavior for polynomials without looking at it graphically. Okay. I don't remember. Did I give you time to copy that? Okay, good. Okay, so we'll just go ahead and get right to it. The resource has a good way of looking at it, but we're just going to go ahead and focus on this stuff on the right over here. So in blue, that's if you have an odd degree, and if it's in green, that means you have an even degree. Because when we're talking about polynomials, we're going to go ahead and try to figure out the end behavior. Remember, that's the far left and the far right side, based on a combination of whether your degree is even or odd, and whether or not it has a positive or negative leading coefficient. Okay, so let's start with the easiest one first. If you have an even degree, okay, if it's an even degree, both ends are going to be going in the same direction. They're either both going to be going up or they're both going to be going down. And it depends on the sign of your leading coefficient. If it's an even degree with a positive coefficient, both ends are up. Okay, if it's an even degree with a negative coefficient, and both ends are down. The only time the ends will go in opposite directions is if you have an odd degree. Okay, so kind of think about looking at my back, I'm the graph. Okay? And if you're at home, you'll have to kind of just visualize this. So if it's an odd degree with a positive coefficient, it's down on the left and it's up on the right. Okay, so what's going to happen if it's an odd degree but it's a negative coefficient? It's going to flip it. So it's up on the left and it's down on the right. Okay, and you may have even talked about this back in Algebra 2. Does any of this seem familiar? Maybe kind of, sort of? Okay, well, let's look at some examples here. So determine the end behavior for the following polynomials. So I'm going to list for each one of these that we do whether the degree is even or odd, and then I'm going to go ahead and say whether the leading coefficient is positive or negative, so I don't have to write it over again. I'm just going to say LC equals leading coefficient. Now, for this set, it says the limit notation is not necessary. But if anybody does want me to write out the limit notation, let me know and I will definitely do it. Okay, so let's start with A. F of x equals 4x to the fifth. Okay, so what kind of degree do we have? Is it odd or even? We definitely have an odd. Now, because it's odd, I immediately know that the left and the right side, they have to be going in opposite directions. They only go in the same direction if it's even. Okay, now, the term that gives you your degree, that's the coefficient you want to look at. So we have an odd degree with a positive leading coefficient. So what would I put for the left end behavior? Is it curving down to negative infinity or curving up to positive infinity? It's curving down. So the left would be negative infinity and the right would be positive infinity. And I can also plug these in the calculator and show you graphically if we're correct or not, if anybody wants me to go ahead and do that for you. Yeah. Okay, you got your back. All right. So that's all we're doing in this section. Again, we're just describing the left and right side, the end behavior. Okay. All right, well, let's take a look at B. I got 1/2 x to the 4th. Okay, well, that's even. So now I know both of these answers are going to be the same. So either both ends are going up to positive infinity or both ends are going down to negative infinity. What kind of coefficient do I have? It's positive. So a positive leading coefficient. So what am I putting for both of these? It's not letting me. There it goes. So what should I put for both? Positive infinity. If it's an even degree with a positive coefficient, they're both up. All right, let's take a look at C. Now, this is the first one where I don't have the actual polynomial. Okay, this one hasn't been expanded for me. And you're more than welcome to try and expand it. I mean, x plus 3 to the 6th, if you're doing it the old-fashioned way, that's going to take a little bit of time. I'm going to show you at some point how to use the binomial theorem, what's called Pascal's triangle, to help you expand those quickly. Does that sound familiar to anybody? Maybe kind of a little bit. Okay, good. But for right now, let's just do like we did in a previous lesson. If I were to take x plus 3 and I multiply it by itself 6 times, well, I'm going to end up with x to the what? What would be the largest power? Yeah, 6, right? Okay. Doesn't matter what the remaining terms are. We don't need that. We just need the degree. Now, of course, I would also, once I get this huge expression, I would distribute the -2. So negative 2x to the 6th would be the first term in my polynomial. Okay. Well, let's see what we got here. I have an even degree with a negative leading coefficient. Okay. So Alexandra, because it's even, these are both up or both down. What do you think? They're both down. So both the left and the right, they're going to be negative infinities. There we go. Is there anybody who is confused or not sure how I'm getting these answers? Questions? Okay. Now, I'm willing to move on at this point. If anybody wants to work D, E, F, or all of them, okay. Does anybody see one that you're like, I'm not quite sure I would get that one right? I want to take a look at it. Does that apply to anybody in here? Okay. Then onward and upward. Okay, example 4. Now, for this one, we do want to go ahead and write limit statements. Okay. So in A, we've got f of x equals -3x to the 4th. So let me go ahead and get my statements ready. So I'm going to say the limit as x approaches negative infinity of f of x. And we have the limit as x approaches positive infinity of f of x. Okay. Alrighty. Now remember, as x approaches negative infinity, that is the left side, the left end behavior. As x approaches positive infinity, that's the right side. That's your right end behavior. Okay, well, what's our combination here? What kind of degree and coefficient do we have? The degree is what? Okay, so the degree is even. So I know both of these answers would have to be the same, and we see that we have a negative leading coefficient. Okay, so now with this combination, what should I put for both of these answers? Negative infinity. It's even with a negative, so both ends are going to curve to negative infinity. They'll go down forever. Perfect. Okay, let's try B. Okay, so the limit as x approaches negative infinity for g of x, and the limit as x approaches positive infinity for g of x. Okay, so let's see what we got here. Bailey, what kind of combination do I have? Degree and coefficient. Okay. So we have an odd degree with a positive leading coefficient. So, Bailey, what would you say about the left end behavior? Should it be going up to positive infinity or down to negative? It's going to go down to negative. There we go. Okay. So, William, what would you say about the right end behavior? Not going to be positive. Remember, if it's odd, the two ends will be going in opposite directions. All right, there we go. Anybody having a hard time? Okay, good. Well, this is how we're going to finish up with this last set. Okay, example 5. It says use a graphing calculator to determine the end behavior for the following functions. And you'll notice for each, I've already got the limit statements ready to go. Okay, so for A, f of x equals x squared minus 3x plus 1. Okay, so let's take a look. So x squared minus 3x plus 1. So I'm going to come on over here to my calculator. Okay. Let's see, so we have x squared minus 3x plus 1. Okay, so we got the graph of a parabola here. So what's the left end behavior? What happens as x approaches negative infinity? Curves up to positive infinity. What's happening on the right end behavior? There you go. Okay, so I'm going to come on back over here. And that makes sense because we have an even degree with a positive coefficient. Okay. Is it working? Oh, there it goes. Yeah, the internet's been kind of off and on today. All right. Now, B and C, this is where it changes. Okay, because those are not polynomial functions. Okay. Now, they're made using polynomials. Can anybody tell me if you take one polynomial and divide it by another polynomial, what kind of function do you get? Starts with the R. Rational. These are rational functions. There we go. Now, once we start looking at rational functions, which is pretty much going to take center stage for a lot of the upcoming lessons that we have, they're going to have something that the polynomials don't. Okay. What do we call those lines that the graphs are going to get infinitely closer to but never touch? Asymptotes. So we're going to be looking at vertical asymptotes. We're going to be looking at horizontal asymptotes. Now, because we're still talking about end behavior, we're going to want to focus on the horizontal asymptote. Okay, now while I am going to go ahead and show you how to find all the information about the rational function, by hand and go ahead and sketch it, right now we haven't gotten that far yet. So let's just plug it in the calculator. So 2x minus 3 over x plus 1. All right, let me document B out of here. Control divide. So 2x, that is out of what I don't need. 2x minus 3 over x plus 1. Here we go. Now, the thing about rational functions, they're going to be infinitely wide. They're going to be infinitely tall in most cases. Okay, but we're still looking at the end behavior. So if I look at the far left, this branch, it's not curving up to positive infinity or down to negative infinity. The branch on the right, it's doing the same thing. Okay, but they are curving towards a horizontal asymptote. They're going to get closer and closer. So looking at this, what do you think we're curving towards? What value? Not -1. Because let me go ahead and go back over here. If I were to go ahead and put the asymptote at -1, we see that intersects my branch. We can't have that. Okay. So where would I put my horizontal asymptote where it looks like these two branches are going to get super close to it? Vera's saying 2. There we go. So in this case, the horizontal asymptote is y equals 2. So the ends, they're not curving towards a positive or negative infinity. Because they're curving towards the asymptote, for these limit statements, we're going to put 2. Now, one branch curves from above, one curves from below. That doesn't change anything. They're both approaching the value of 2. They just won't ever get there. All right, questions on that? All right, so with this in mind, let's try C. So we're going to have the negative 10 over x squared. Okay, so let me erase this real quick. Document B. Okay, control divide. We got a negative 10 over x squared. Okay, here we go. I'm going to push enter. So here is the rational function. Negative 10 over x squared. So again, if you notice, the left and the right end behavior, they're not going ahead and curving to any infinity. Where do you think the horizontal asymptote is? What would you say in this case? Ayla? It looks like you just did it with your hand. 0. That's exactly right. Yes. Okay, so let me get my marker here. So yes, it is curving towards y equals 0. Absolutely right. So if I go back on my paper, and I'm going to go ahead and fill in these limit statements here, this will pop up. What are both of these going to equal? 0. Yes. Okay. Now, this is if you have a horizontal asymptote. Let me ask you a real quick question. Let's see what you can remember from Algebra 2. I'm looking at my student. Okay, so is it possible for the end behavior of a rational function to ever curve towards positive or negative infinity? What do we think? Yes or no? Okay, Maya's shaking her head yes, and she's absolutely right. That will happen if we have what type of asymptote? It's not horizontal. We're not vertical. Now, vertical, we will be looking at the behavior of that, but is it possible we have a slant asymptote? Anybody remember working with those? Okay. Mathematically, we say they're an oblique asymptote. That's the math term. I've always said slant. Okay. I don't know. The other one just kind of has an oblique outlook on things. Okay. All right. That was good, right? Yeah. Okay. Let's make sure. Okay. All right. So, questions. Anybody have any questions? How we doing? Okay. All right. So with that, we are done with 1.6. Let me go ahead and set up for the next class, and then I'm going to go ahead and give you some instructions, because now we're going to go ahead and do this activity. Yes. Do you have your badge? Okay. Got to make sure you are who you say you are.